Hi, this is Jason with Liquid Instruments. Today I'm going to show you how to measure Allan deviation with the Moku Time and Frequency Analyzer. If you're familiar with Moku, you may know that our Phasemeter instrument also has an Allan deviation measurement function available. However, this Phasemeter also has a lower limit on its input frequency of 9 kHz. So the method I'll show you today can work in situations where your measured clock signal is below the Phasemeter limit. Let's start by opening multi-instrument mode and putting the Time and Frequency Analyzer in slot 1 and the data logger in slot 2. We don't need to make any changes to connections, so click Apply Changes and wait for it to configure. Let's open the data logger first. We'll be using the embedded waveform generator to make our clock signal. Click on the icon in the lower right and generate a sine wave of 50 Hz. Enable the output if it's not already. So now that we're generating our clock signal, let's return to the Time and Frequency Analyzer and click over to the Events tab. We're only measuring one event this time, which is when the clock signal crosses the threshold of 0 volts on a rising edge. Click back over to the Intervals tab. Let's look at the current interval and the mean interval. You can click the plus sign on the left to add these statistics if they are not displayed. Set the acquisition mode to continuous, and we see that the mean is about what we expect for a 50 Hz signal, around 20 milliseconds. Click over to the Output tab and enable Output A, and set the signal to interval if it's not already. This will generate a voltage signal that scales to the magnitude of the interval. Set the 0 point to be 20 milliseconds, and the scaling to 500 kilovolts per second. We choose the scaling factor so that the output signal is maximally sensitive to changes in the period. Keep track of these scaling numbers or set them using the Python API, as they will be needed to convert the time data back into fractional frequency. Returning to the data logger, we can now see a stream of voltage data coming in to input A. We set our sampling rate to something lower than the frequency we're measuring, so we'll start with 15 samples per second in precision mode. To log this data, we set the timer on the right-hand side, for example 10 seconds, and click the red dot to acquire. The data will start to log. Once the collection has finished, the data can be moved to a measurement PC by clicking on this cloud icon. As an example, we're going to take the most recent data set and convert it to a CSV format and move it to my downloads file. Opening up one of these CSV files, you'll see a list of timestamps and voltages that correspond to period information. Using a script, these values can be easily converted back into fractional frequency for calculation of Allan deviation. If you'd like to see the Python script that performs this operation, check the description for a GitHub link. That's all for today. See you next time.